All right, we're going to do the Lewis structure for BeF2. Okay? First step in doing a Lewis structure for a molecule is to start with the first atom. So in this case, it's Be. So we're going to write Be. Okay, we're going to start with the first one. To get your valence electrons, you look at your periodic table, which is on the screen or on the wall, and Be is right here. It is in row 2. If I look at the screen, I can't do it. Can't look at the screen. It is in row 2. So that means it has how many valence electrons? 2. So we just put 2 dots. You can put them on top and bottom, top and side, bottom and side. It doesn't matter as long as you don't put them next to each other. Okay? I like to put them opposite of one another because you're going to be bonding the F's, and it is way easier, gives yourself more room if you put them opposite of each other. Now, let's pause for a second. If Be only has 2 valence electrons, is it ever going to make it to 8? Does it fit any of our exception rules? What's number 2 say?
Elements with less than 4.
That's okay. Elements with 4 or less than 4 electrons are not going to make it to an 8. So if beryllium only has 2, are we worried about getting beryllium to 8? Nope. So we know it's never going to get to 8. So we can just keep that in mind as we're going. How many fluorines do we have in this molecule? 2. Where do you think we're going to bond the fluorines if we want them to share electrons with beryllium? Perfect. These 2 dots, they're already marking our spots. So next to our dots, leaving a little bit of room, we're going to put our F's. Okay, now let's go back to the periodic table. Here's fluorine. How many valence electrons does fluorine have? 7, because it's in 17. We ignore the 1. Fluorine has 7 valence electrons. So we're going to put our 7 dots. One thing, note, put your 1 by itself next to beryllium. 7, 1, 2, 3, 4, 5, 6, 7. Okay? The reason I told you to put the 1 here by itself is because it's going to make a prettier picture. It does not matter. Okay? It makes 0 difference where you put your electrons. Why? Do we know where electrons live? No. Remember from before Christmas, electrons have no specific position, and at any given time, they're moving so much nobody has any idea where they are. So while it doesn't matter where you put your electrons, setting them up like this in a little square makes for a very, very pretty, not confusing Lewis structure. So just take that as a hint. Okay? All right, so fluorine has 7 valence electrons. So is it going to get to 8? Does it have more than 4? Yep, it's going to get to 8. And how, looking at this picture, do you think we can get it to 8? Perfect. It's going to share Be. So I'm just going to draw a little circle right here and right here, showing that those 2 are holding hands. They are bonded together. They're in love, and it's going to take a lot of energy to break that bond. Somebody's going to have to work really hard to steal fluorine from beryllium.
I just put a text message out on social media.
Text messages don't break up atoms. They are too in love. Some atoms aren't,
Just
but
add a new element.
some atoms are pretty frisky. These are not.
What did she say?
Just wait till you watch I have a crash course called Atom Hookups.
No, I don't like the crash courses. They're so
It's a dating show for atoms, because that's what they're doing. All right, my people in quarantine are going to watch this and be like, what is going on? All right, so beryllium and fluorine are now bonded. I can't look at the screen. I already get dizzy. These 2 electrons inside my circle count for beryllium and fluorine. Okay, so beryllium now has 1, 2, 3, 4 electrons to it. It gets to share the ones in the circle. Fluorine now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Fluorine over here has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Both of our fluorines wanted to get to 8 for the octet rule. Are they happy? Did beryllium need to get to 8? Nope, because remember it has less than 4 valence electrons. So everybody's happy. We're done. Okay? Not too hard. Pretty easy, right? All right, let's do another one. I got to go back to my practice problems because I forget them. Let's do CCl4. I'm going to slide the paper. All right, so we're going to do CCl4. Need to slide that a little bit more. There we go. Okay. One note. I will never give you CI. Okay, I know that the big push has been to use Arial font on stuff. That's the new proper font. When I grew up, it was Times New Roman, but now it's Arial. And everyone thinks this is a capital I. It's not. I'll never, ever, ever give you CI next to each other because that will confuse the heck out of you. It's CL. Always assume it's CL. Okay? All right, so we have carbon and 4 chlorines. What do we start with? Which atom do we do first? C, the first one. So we'll put a C. Flip. C is carbon. So we go to our handy dandy periodic table. Y'all ever watch Blue's Clues? Handy dandy periodic table. Carbon, it's in row 14. How many valence electrons does it have? 4. So go ahead and put your 4 dots. Remember, it makes for a prettier picture if you space them out. Now, being the geniuses that you are, how many chlorines do we have? 4. And how many spots do we have to put one? 4. Look how that works out. So go ahead and put a chlorine next to every one of these little dots, leaving yourself room again to hold hands. So funny how everything in chemistry just works out magically. It's almost like I did it on purpose. All right, back to our periodic table. Giroux, how many valence electrons does chlorine have? It's right here. What? What, Drew?
What?
You said something, but I didn't hear you.
Probably wrong.
No, say it louder. You were right. 7. I'm going to ignore the team part. We just ignore the what. So 7. So go ahead, draw your 7 dots. Remember, if you put your 1 here, it makes life easier. Whew. A lot of dot drawing.
This is like all we did, and the little boxes with the little arrows. That's it.
We won't do that anymore. We're done with that. So now, can you guess where they're going to hold hands? In the middle. Where there's one by itself, it's going to find another one. Hold hands. Ta-da!
Hey, that's a lot of freaking dots.
It's a lot of dots. So now let's check and make sure. Every chlorine has 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And our carbon has 2, 4, 6, 8. Everybody's happy and we're done.